It is given the next information. In this question you will explore some of the properties of special functions f and g and their relationship with trigonometric functions sine and cosine. Functions f and g are defined as f is equal to this expression, g is equal to this expression, where z is a complex number. Consider t and u such that t and u are real numbers. A. 2 marks. Verify that u is f of t satisfies the differential equation. The second derivative of u with respect to t is equal to u. So we need to find the second derivative of u, and u is e to the power of t plus e to the power of negative t over 2, and we know that e to the power of t derivative is the same e to the power of t, and e to the power of negative t derivative is negative e to the power of negative t. Hence the first derivative becomes e to the power of t minus e to the power of negative t over 2, and hence the second derivative becomes e to the power of t minus minus, so plus e to the power negative t over 2, and we can see that it's u as required. B. 3 marks. Show that f of t squared plus g of t squared is f of 2t. So let's consider the left hand side. F of t squared plus g of t squared is, what is f of t? F of t is e to the power of t plus e to the power of negative t over 2 squared, so we can write as squared over 4, plus e to the power of t minus e to negative t squared over 4. And applying a formula, a plus minus b squared is a squared plus minus 2ab plus b squared, we get the next. We can write the common denominator over 4, so e to the power of 2t plus 2e to the power of t e to negative t plus e to negative 2t plus e to the power 2t plus, not plus, minus 2e to the power of t e to negative t plus e to the power of negative 2t, and it becomes 2 times e to the power 2t plus e to the power of negative 2t over 4, or e to the power of 2t plus e to negative 2t over 2, and we can see that it's function f of 2t as required. C. Using e to the power of iu is cosine u plus I sine u. Find expressions in terms of sine and cosine of u for I f of I u and I g of I u, 3 and 2 marks respectively. So f of I u, what is f? It's this function, so it becomes e to the power of I u plus e to the power of negative I u over 2, and it becomes cosine u plus I sine u plus cosine of negative u plus I sine of negative u over 2, and we know that cosine is even function, so cosine of negative u is cosine u, and sine of negative u is negative sine of u, so it becomes 2 times cosine u over 2. So it's cosine u. And g of iu becomes e to the power of iu minus e to negative iu over 2. And similarly, it becomes cosine u plus I sine u minus cosine of negative u minus I sine of negative u over 2. And we can see that it becomes cosine minus cosine, and I sine minus minus, so plus, so it's 2I sine u over 2, and it's I sine u. D. D. 2 marks. Hence find and simplify an expression for f of iu squared plus g of iu squared. 2 marks. Hence it means we must use the previous result, and f of iu it's cosine, so it becomes cosine squared of u, plus g of iu it's I sine of u squared, and it becomes cosine squared. I squared it's -1, so it's minus sine squared, and it's formula of a double angle, so it's cosine of 2u of double angle. It's 2u, cosine of 2u, and it's the required answer. The next E shows that f of t squared minus g of t squared is f of iu squared minus g of iu also squared. 4 marks. Okay, so show that. Okay, so let's consider the left hand side, f of t squared. And we did with plus, but we need with minus. But it's quite easy. It's again e to the power of t plus e to the power of negative t squared minus e to the power of t minus e to negative t squared. And it is equal to e to the power of 2t plus, it will be 2 multiplied by e to the power of t plus e to negative t, it's just 2 plus e to negative 2t minus e to the power of 2t, and it's minus 2, and with this minus it becomes plus 2, and plus, but with this minus it becomes minus e to the power of negative 2t. And we can see that it becomes 4 over 4, it's 1. And let's consider the right hand side. The right hand side becomes f of iu squared, it's cosine u squared, so cosine squared of u, and minus g of iu squared, it's I sine of u squared. I sine of u squared, and it becomes cosine squared of u plus sine squared of u is 1. And as the left hand side is equal the right hand side, statement is true, so it's true. It's true. The next, the functions cosine of x and sine of x are known as circular functions, as the general point cosine and sine of theta defines points on the unit circle with equation x squared plus y squared is 1. The functions f of x and g of x are known as hyperbolic functions, as the general point f of theta and g of theta defines points on a curve known as a hyperbola with equation x squared minus y squared is 1. This hyperbola has two asymptotes. Okay. F. 4 marks. Sketch the graph of x squared minus y squared is 1, stating the coordinates of any axis intercepts and the equation of each asymptote. Okay. So if we consider intercepts when x is 0, y, it becomes minus y squared is 1, so there are no y intercepts. And if we consider y is 0, we get x squared is 1, so x is plus minus 1 are x intercepts, so negative 1 0 1 0 are x intercepts. And if we consider asymptotes, how to find asymptotes, it means when x tends to plus minus infinity, it means when x is very large, it means that 1 will be much less than x and we can ignore it. It will be negligible. So when x is very large, it acts like y squared is x squared, and hence y is plus minus x. It's just general solution of this equation. So asymptotes are y is x and y is negative x. And hence this graph of x squared minus y squared is 1 becomes -1 and the asymptote, so it looks like this. Y, x, origin. Okay. The next, the hyperbola with equation x squared minus y squared is 1 can be rotated to coincide with the curve defined by x, y is k, where k is real. G. Find the possible values of k. 5 marks. It means that if we rotate this graph, it will coincide with the usual hyperbola 1 over x, or some coefficient actually over x. It may be like this or like this. And we can see that since asymptotes are y is x, y is negative x, it means that this angle is 45 degrees and this is also 45 and this is also 45 degrees, and let's find this point. It's like a new coordinate system, x primed, y primed, or just let's find the distance from origin to this point and from origin to this point. So since it's 45 degrees and this distance is 1, so it's just a right angle triangle, hypotenuse is 1 and we need adjacent leg, it's cosine, so 1 cosine 45, so it's root 2 over 2, and also this is also root 2 over 2 because it's 1 sine 45 degrees, it's root 2 over 2. And if you rotate this graph by 45 degrees in anti-clockwise direction, actually this y primed and x prime axis becomes as usual coordinate system, and our hyperbola will look like this, and our point, which is 1, 0 here, will be these values, root 2 over 2 and root 2 over 2. And since it's a point of new graph, rotated graph, we know that to find some unknown parameter, if we know any point on the graph, we can substitute it and find k. So we can substitute root 2 over 2 for k and root 2 over 2 for y, and we can see that it becomes 2 over 4 or a half, and it's the first possible value of k. But we can rotate by 45 degrees in clockwise direction, so that we get hyperbola in the second and the fourth quadrants, and it will look like this, and you can see that our point 1, 0 will be after rotation, it will be root 2 over 2 and negative root 2 over 2. It will be y primed and x primed. It doesn't matter actually, it's not needed to draw these new graphs, you need just find the possible k values, and hence we can see that a point on the new graph is root 2 over 2 and negative root 2 over 2, so we can substitute root 2 over 2 for x and negative root 2 over 2 for y, and get that the second possible value of k is negative a half. So possible values for k are a half and negative a half. And that's all for this question.